This video will discuss chapter 7.2, dividing monomials. So similar to multiplying monomials, there is a shortcut, but let's first make sure that we understand the long way. So this is t to the sixth divided by t squared. So this could be the same as writing t times t times t times t times t times t, right? 1, 2, 3, 4, 5, 6 divided by t times t. Now, I'm able, at this point, to then cross out, so I can take 1t from the bottom and 1t from the top. 1t from the bottom, 1t from the top, or from the denominator and numerator. I should probably use the appropriate terms. And so I'm left with these 4 t's. So this is the same as t to the fourth. Right now, if you think about it, it should be a higher. If you think about it, the shortcut then, similar to the way that when you were multiplying monomials, you added, this one is dividing. Division is the opposite of multiplication. So we're going to do the opposite of addition. We're going to take these. You can subtract 6 minus 2, and you end up getting t to the fourth. Right? So this would be the long way so you can actually see why this magic trick or this shortcut works. But keep in mind that you are able to subtract. So if we use that, we'll solve this problem. Keep in mind that there is a 1 here. Right? So when I solve this, I'm going to go g, 3 minus 1. 3 minus 1 is 2, so this is g to the second. And then h, these are both h's, so 5 minus 2, this is h to the third, h cubed. G to the second, h to the third, when I'm dividing g to the third, h to the fifth, divided by g, h squared. Right? So remember, there is that 1 there, but we can just assume that it's there. All right, what happens when you get a problem like this? This is a fraction that has a exponent on the outside. So keep in mind that this is just a number, right? It's a division problem, and so this 2 is going to, this 3, this exponent of 3 is only working on the p, whereas this 2, the squared, is working on everything inside, which means it's working on the 3, the p to the third, and the 7, or the 1/7 if you want to look at it that way. So I'm going to take 3 squared, which is 9. I'm going to take p cubed squared, or p to the third squared, and this is p to the sixth, right? I'm multiplying. And then 7 squared is 49. This is 9 p to the sixth over 49. Right? So this squared works on everything inside of the parentheses. Keep that in mind when you get some of these fractions. All right, so the next thing I want to talk about is the power of 0. Right, and so we'll come back to this in just a second, but I want you to notice that 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. Most people will agree with this. Hopefully you agree with this. Okay, and so you'll notice that as I go from 2 to 4 to 8 to 16, what I'm doing is I'm multiplying by 2, right? I'm doubling. And so that's because 2, this has 1, 2, 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. But I want you to think of it now the other way. What if I go like this? Right? So you might think of this as dividing by 2 or multiplying by 1/2, which means that as I go and I continue the pattern here, I would have to take 2 and divide by 2, and 2 divided by 2 is 1. Okay, so one thing to keep in mind is that anything to the 0 power is 1. I want to show you another way that you might see this. Using the trick that we just talked about, if I go n to the fourth divided by n to the third, we just said that you can subtract these, right? So this would become n to the first, or just n, depending on how you want to write it, right? And so this is n. Well, then n to the third divided by n to the third means it's a number divided by itself. 7 divided by 7 is 1. 12 divided by 12 is 1. n to the third divided by n to the third should also be 1. And if you take a look at this, this is 3 minus 3, which means that this is going to be n to the 0 power, and so that is 1. So kind of 2 ways to see why something to the 0 power is 1. This would be 1, right, and this might be another way. But it's really important that you understand that anything to the 0 power is 1, because that's something we're going to kind of use in this next problem. And the last thing, before we get to the next problem, that I really want you to see also is negative exponents. So if you agree that anything to the 0 power is 1, we now have 2 times 2 is 4, 2 times 2 times 1 basically is 2, 2 to the 0 is 1. The question is, what is 2 to the negative 1? What is 2 to the negative 2? So again, when we went this way, we were multiplying by 2, right? And we kind of continued that pattern on for a while in this and kind of went all the way down. So I'm now moving back up this way. So you're dividing by 2, divide by 2, divide by 2, divide by 2. I would have to continue that pattern. Divide by 2 or multiply by 1/2. 1 divided by 2 is 1/2. And this would be divide by 2 or multiply by 1/2. This would be 1/4. Now, another way that you could see this is 2 to the first, 2 to the second, this is 2 to the 0. 2 to the negative 1 is the same as 1 over 2 to the first power, right? This says the same thing. And this would be the same as 1 over 2 to the second power. So a lot of times people talk about negative exponents as meaning it's 1 over, and then this becomes positive when you flip it, right? So I could rewrite this that way. So for example, something like n to the negative third is the same as 1 over n to the third. Right? These two say the exact same thing. And a lot of times, or most of the times I would say, people will write it this way, but this negative kind of helps it. So if I just want to write one long line, I can go positives and negatives. So keep in mind the 0 and the negative. Let's take a look at a problem like this. So remember, this is a division problem. So a lot of people think of this as subtraction. They start subtracting these two numbers. We're not. We're dividing them. And so one way that people will rewrite this, and you don't necessarily have to rewrite it like this, but they'll separate the terms. So those are the numbers, 5 and negative 20. And then I got r to the negative third over r squared. I then have t to the fourth over t to the seventh. And then I have what a lot of people will see as 1 over v to the negative fifth. Right, but then remember what I can rewrite 1 as. So instead of writing it as 1, I'll write it as v to the 0, which is the same as 1, right? Because there are no v's up on the top, so there's 0 v's. V to the 0. All right, now as I simplify this, yeah, that's not going to come out. Let's stick with the black. This becomes negative 1/4 times, this is going to be negative 3 minus 2, right? Because I'm subtracting. Negative 3 minus 2 is r to the negative fifth times t to the fourth divided by t to the seventh. So 4 minus 7, t to the negative third times 0 minus negative 5. Now be careful there. 0 minus negative 5 is going to give me v to the fifth. Right? So as I rewrite this in proper form, this is going to be negative. I don't necessarily need to put this 1. Right? So I can kind of start my fraction. I got a 4 on the bottom. This r to the negative fifth is the same. And if you come back to this, remember n to the negative third is the same as n to the third. So r to the negative fifth is the same as 1 over r to the fifth. Right? So that's going on the bottom. T to the negative third, this is going on the bottom, and then v to the fifth is actually going to be on top. So remember, and don't forget the negative sign. Negative v to the fifth over 4r to the fifth t to the third. Okay, so one way is to separate these. Eventually, I think people get comfortable doing some of this stuff in their head, but I wouldn't necessarily jump there immediately because you want to make sure that you're not subtracting. Sometimes people end up subtracting, these numbers, and t and v do not have the same base. So you have to have the same base in order to use this subtraction trick. That's all we got for you on dividing monomials. Thanks for watching the video. Don't forget to do the problems on the bottom page. I'll see you in class.